So to get a pretty accurate value for sine x and cosine x without having to actually use trigonometry, you can use the Maclaurin series with a few terms to get a pretty accurate value. So right at the top, you can see those equations. You should use x in radians, and you're going to get good answers the closer it is, the closer x is to 0, and then anything over 1 is it's not going to work. So to kind of just explain it, if people are interested, for the Maclaurin series, pretty sure it's a Taylor series, but centered at x equals 0. So what this is saying is we're going to take a summation from n equals 0 to infinity of f to the nth derivative of our function, and then we're going to plug 0 into that, divide it by n factorial, multiplied by x to the nth power. So down here I just calculated, so we're going to do this for sine x, and then I took all the derivatives we're going to need in sine x eventually. You can see it repeats. So our first derivative is going to go cosine, then minus sine x, and so on. Now, to find our first term in n equals 0, we'll simply take our original function, plug in 0, over 0 factorial times x to the 0. 0 factorial is 1, and x to the 0 is 1. So we get sine evaluated at 0, which is going to be 0. And that pattern is going to repeat. Every time we have a sine, it's going to be sine of 0, which will be 0. So we will not have any even terms, any for n equals 0, 2, 4, and so forth. And then for our odd terms, for n equals 1, we'll take f prime x, which is going to be cosine x. So we'll evaluate cosine x at 0 times x to the first over 1 factorial. We'll get this. That's going to equal 1 times x, which is x. And you can look at the work. We'll continue this, and we'll only do this for n equals 0 through n equals 5. This is a summation, so we'll add together those terms. And this down at the bottom, which is also at the top, that's going to be pretty accurate enough that you're going to see it's the same thing as if you just did sine of x in radians in your calculator. Of course, you could repeat this, and the idea is if you did this for an infinite amount of terms, you'd get an exact value. Alright, hopefully this is what you were looking for.